Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this chapter, we are going to review lines. You'll learn how to figure out if a specific point exists on a particular line. You'll learn how to calculate the slope of a line, the equation of a particular line, given properties of the line such as a specific point, 2 points, and/or the slope of that line. We'll also discuss parallel lines, perpendicular lines, as well as how to graph linear equations and inequalities. Should you have any follow-up questions, feel free to leave them in the comment section. Or, of course, you can connect with a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's kick things off by discussing the coordinate plane. A coordinate plane is a tool used to measure the distance between 2 points and the steepness of a line. So this is our coordinate plane. It's a two-dimensional figure that helps us lay out points in space. So these are our 2 points that exist on this line here. So we'll be able to use a coordinate plane, our x and y axes, which we'll discuss more in a second. We're able to use this set of axes to figure out the distance between these 2 points, as well as the steepness. The steepness is how quickly this line rises over how quickly it's crossing horizontally. And we'll discuss slope thoroughly later on in this chapter. The horizontal line here is called the x-axis. The vertical line here is called the y-axis. And as we see, they intersect, forming perpendicular lines or 90-degree angles at each one of these 4 angles here. So this is 90 degrees, this is 90 degrees, this is 90 degrees between the 2 black lines, and this is 90 degrees as well, giving us a total of 360 degrees all around in our two-dimensional space. Now, a point is defined in a coordinate plane by its location along the x and y axes. And a point is usually given to us as a coordinate. The first number in that coordinate inside our parentheses is the value of the x, and the second value inside the parentheses is the y. And as we see here, they are always separated with a comma. So this point here has a location of 3, 3. This first 3 represents the x value, which is this number. The second number represents our y value, which is here. So this point is positive 3 along the x-axis and positive 3 along the y-axis. Hence the coordinate 3, 3. Now, how do we know that these are positive? To the right of this y-axis are the positive x values, and to the left of the y-axis are the negative x values. So here we have our positive values as we move away from the origin. And here we have our x values as we move to the left. With the y values above the x-axis, so above the horizontal line, are the positive y values, and below the x-axis are the negative y values. So knowing this helps us figure out what values each point has in this overall coordinate plane. So this point has a negative x value since it's to the left of this y-axis. It's negative 3. And you have to go down, which means we're going below the x-axis, which means its y value is also going to be negative. So we have positive x, positive y in this quadrant, negative x, positive y in this one, negative x values and negative y values in this one, and positive x values and negative y values in this one. Now, the x and y axes intersect at the origin, or where both axes have a value of 0. So here at the center, x is 0 and y is 0. And as we move to the right, they become positive for the x, or to the left, they become negative for the x. As we move up, we get our positive y values. As we move down, we get our negative y values. But where they meet, both have a value of 0. This is also known as the origin. Now let's discuss lines a little bit. A line is a collection of points between the first point and the second point. Now which point you choose as your first or second point is up to you. This one can be considered your first point, and this one can be considered your second point, x2 and y2. Conventionally, since we read left to right, the point furthest to the left is considered our first point, or at least that's what I'll be using throughout this video. And as you move to the right, you get your second point. But as you're calculating different values, it actually does not matter. You can use the first point as x2 and y2, and this point as x1, y1. Just make sure this x value and this y value stay together, and this x value and y value stay together. That's the most important thing. Let's discuss the standard form of a line. If an equation can be written in this form, ax plus by is equal to c, where a and b cannot both be equal to 0, it is called the standard form of a line. So what does this mean? The standard form can be used to confirm whether or not a specific point, xy, exists on a line. So a line is a collection of points, and in standard form, we can figure out if any one of these particular points exists on the line given. You would be given a question like this one. Is the point 2, 3 on the line negative 3x plus y is equal to negative 4? So this is our standard form. We have our x and y on the same side of the equation and the constant on the right side of the equation. So how do we figure out if a specific point given to us exists on this line? There's really one step to figure this out. You plug the point into the equation. So we take the equation in standard form, negative 3x plus y is equal to negative 4. We plug in 2 for x and 3 for y. This is our x coordinate, this is our y coordinate. So when we plug in 2 for x and 3 for y, we get negative 3 times 2, which is equal to negative 6, plus 3. Negative 6 plus 3 is equal to negative 3. And when we plug in this particular coordinate, the left side of the equation does not equal the right side, which means this is not true. And if the equation is not true, then the point is not on this line. So the answer would be no, 2, 3 does not exist on the line negative 3x plus y is equal to negative 4. If you were given a value that did work, so if we did get negative 4 is equal to negative 4, then we know that the point does exist on this line. So that is how you figure out if a point is on a line. Let's have you do a few practice questions. Is the point 1, 1 on any of the following lines? Question number 1, 4x plus 2y is equal to 6. Question number 2, negative 5x minus 3y is equal to negative 4. And question number 3, negative 20x plus 4y is equal to negative 16. Pause the video, answer these questions, and then press play when you are ready to begin. Question 1, Step 1, plug the point into the equation. So we have the same point for each one of these questions. It's positive 1, positive 1. So we plug in 1 for x and 1 for y. And we get 4 times 1, which is 4. 2 times 1 is 2. 4 plus 2 is equal to 6. And since the left side equals the right side, we know that this point, 1, 1, does exist on this line. 4x plus 2y is equal to 6. Question number 2. Step 1, plug the point into the equation. We plug in 1 for x and 1 for y. Negative 5 times 1 is equal to negative 5. Negative 3 times 1 is negative 3. Negative 5 minus 3 is equal to negative 8. Since the left side does not equal the right side, we know that this point, 1, 1, does not exist on this line. Negative 5x minus 3y is equal to negative 4. Then the last question. Step 1, plug the point into the equation. Negative 20x plus 4y is equal to negative 16. Plug in 1 for x and 1 for y. You get negative 20 times 1 is negative 20. 4 times 1 is 4. Negative 20 plus 4 is negative 16. Since the left side equals the right side, that confirms that 1, 1 does exist on this line. Negative 20x plus 4y is equal to negative 16. Let's now discuss the slope of a line. The slope is the steepness of a line and can be calculated if 2 points along the line are known. So the slope is equal to the change in y over the change in x, which is commonly known also as rise over run. So what does that mean? Well, the vertical distance between the y points is also known as the rise or the change in y. So we're moving from this y value to this y value. That distance is how much we are rising. The horizontal distance between the x points is known as the run or change in x, the delta x also. So the run is how far our x point here is from our x point here. That's the horizontal distance. And again, together, the change in y over the change in x gives us the steepness of the line, which is also known as the slope. The change in y is the same as subtracting the first y value from the second, the first x value from the second, or vice versa. If the second point is above the first point, then the slope will be positive. By second point, I mean if you're looking at the coordinate plane from left to right, the second point is the one furthest to the right. So since this point is above the first point here, that's how we know this slope here is positive. If it's going the opposite direction, if the second point is below the first point, then the slope will be negative. Upward sloping positive, downward sloping negative. A few unique cases are a completely vertical line and a completely horizontal line. If a line is completely vertical, that means it is all rise, change in y, but no run. There's no change in x. It's the same x value for all of these points. Anything divided by 0 is undefined. That is why a vertical line has a slope that is undefined, since there is no change in x. A horizontal line has a slope of 0, since there is no change in y. So this is all run. All of these x values are changing. But it's the same y value, so there's no change in y. 0 divided by anything is 0. Let's walk through how to calculate the slope of a line if we are given 2 points on that line. Step 1, subtract the second y-coordinate from the first y-coordinate. Again, I'm considering the second coordinate the one furthest to the right. The first point is one to the left, the second one is the one furthest to the right. but I'll also calculate the slope using this one first and this one second. And you'll see that the answer will wind up being the same. So subtract the second y-coordinate from the first y-coordinate. So it's -5 minus 5. That's our change in y, which will give us -10. And if we look, if we're going from -5 up to +5, from -5 to the x-axis would be 5. From here to +5 would be another 5, so it'd be a distance of 10. Step 2, subtract the second x-coordinate from the first x-coordinate. So our first x-coordinate is -3, minus the second x-coordinate, which is 4, which that gives us -7. And then step 3, divide the change in y by the change in x. A negative divided by negative becomes positive. So the answer is 10/7. That would be the slope of this line. Now when doing this, I considered this our first point and this our second point. As I mentioned, if you use the point furthest to the right as your first point and the one to the left as your second, you'll wind up with the same overall slope. You would get 5 minus -5, minus a negative would be positive, and you get 4 minus -3, minus a negative would turn this into a positive, so 4 plus 3 would be 7. So you'd still wind up with 10/7. As long as you use these together and these together, the final slope will be exactly the same. Let's have you try a few practice questions. Find the slope of each line. Question number 1 is this green line. -2, 5 is this point here. And +3, 2 is the point here. Question number 2, the blue one. -3, 2, and 2, -4. In question number 3, purple, -6, 0 is this point, and +1, 4 is this point. Pause the video, find the slope of each of these lines, and then press play when you are ready to begin. So for each of these, our first point will be the one furthest to the left, and our second point will be the point furthest to the right. So question number 1, step 1, subtract the second y-coordinate from the first y-coordinate. So that would be 5 minus 2 in our numerator, which gives us +3. Step 2, subtract the second x-coordinate from the first x-coordinate. So that gives us -2 minus 3, which gives us -5. And now step 3, divide the change in y by the change in x. 3 divided by -5 gives us -3/5. And we see this line is downward slanting. The second point is below the first point. So we know this slope was supposed to be negative. Question number 2. The 2 points we had were -3, 2, and 2, -4. Step 1, subtract the second y-coordinate from the first y-coordinate. That gives you 2 minus -4. Minus a negative turns it into addition. 2 plus 4 equals 6. The distance between +2 and -4 has a total distance of 6. Step 2, subtract the second x-coordinate from the first x-coordinate. That gives you -3 minus 2, which is -5 in the denominator. Step 3, divide the change in y by the change in x. 6 divided by -5 gives us -6/5. And again, our second point is below the first point, so this slope was supposed to be negative. Question number 3. We had the 2 points -6, 0, and 1, 4. Step 1, subtract the second y-coordinate from the first y-coordinate. That gives us 0 minus 4, which is -4 in the numerator. Step 2, subtract the second x-coordinate from the first x-coordinate. So we're subtracting 1 from -6. -6 minus 1 gives us -7. We divide a negative by a negative, we wind up with a positive. So step 3, we divide the change in y by the change in x. We get positive 4/7. The second point is above the first point, so this line does have a positive slope, as we were expecting. Let's now discuss the slope-intercept form. The slope-intercept form is a way to express the equation of a line using the slope, m, and the y-intercept, b, of the line. So we just discussed the slope. The y-intercept is the point along the y-axis where the line crosses. So the equation of a line, slope-intercept form, has y on one side and the slope and y-intercept on the other. And it's given this general form, y is equal to mx plus b, m being the slope of the line, and b being where the line crosses the y-axis. So if this line is crossing here at +6 and it has a slope of +2, then the equation of this line is y is equal to 2x, the slope m is replaced by the actual slope 2. So 2x, and the y-intercept is +6, so it's +6. So this would be the equation of this line. And again, all we were given were the slope and where this line crosses the y-axis. If we had another line, let's say it had a slope equal to -3, and it crossed the y-axis at +2. The equation of this line would be y is equal to -3x plus 2. Let's say you are asked to find the slope and y-intercept of 2y plus 6x is equal to 4. Well, in order to do so, we want to get this in slope-intercept form. So we want to isolate y on one side of this equation. So step 1, we'll subtract 6x from both sides to negate this positive 6x, leaving us with 2y on one side of the equation. We'll have the x term first, just to keep it in y is equal to mx plus b form. So we'll keep the x first. Step 2, divide both sides by 2 to get rid of this coefficient 2. When we do so, we have y on one side, and then -6 divided by 2 gives us -3x, plus 4 divided by 2, which is +2. So now that we have it in slope-intercept form, we know that the slope is the coefficient of our x term, which is -3. So m is equal to -3. And the y-intercept is the constant beside our x term. So it's +2. So that is how you would find the slope and y-intercept of a line if the equation were given in standard form. Let's have you try a few practice questions. Find the slope and y-intercept of each. Question number 1. 2y minus 4x is equal to 10. Question number 2. 3y plus 9x is equal to 15. And question number 3. 4y minus 16x is equal to 24. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1. Remember, we want to isolate our y term. So the first thing we're going to do is add 4x to both sides to negate this negative 4x. That gives us 2y on the left side and positive 4x plus 10 on the right side. We put our x term before our constant just to keep it in mx plus b form. Now we want to get rid of this coefficient 2. So step 2, divide both sides by 2. That gives us y on the left side. 4x divided by 2 is 2x. And positive 10 divided by 2 is positive 5. So now we have the equation of the same line. This is equivalent to this. We have the equation of the same line, but now it's in y is equal to mx plus b form. So m, or the coefficient of x, is 2. So that is our slope, positive 2. And our constant is positive 5. So that is our b, or our y-intercept. Question number 2. We were given 3y plus 9x is equal to 15. We want to isolate this y. So the first thing we do is negate this 9x. So step 1, subtract 9x from both sides. That gives you negative 9x plus 15 on the right side, 3y on the left side. Step 2, divide both sides by 3. That's how we get rid of this coefficient 3, giving you y is equal to negative 9x divided by 3 is negative 3x. Positive 15 divided by 3 is positive 5. So mx plus b shows us that our m, or our slope, is equal to negative 3. And our b is positive 5, which is our y-intercept. Question number 3. We were given 4y minus 16x is equal to 24. Step 1, add 16x to both sides, leaving you with 4y on the left side and positive 16x plus 24 on the right side. Now you want to negate this coefficient 4. So step 2, divide both sides by 4, leaving us with y is equal to 16x divided by 4 is 4x. Positive 24 divided by 4 is positive 6. So now we have the equation of the same line in mx plus b form with our y isolated. So our m, or our slope, is equal to positive 4. And our y-intercept, or b, is equal to positive 6. So if you want to find out the slope and or the y-intercept of a line, take the equation of the line and isolate y on one side and place the other side in mx plus b form. Your slope will be the coefficient of x. Your y-intercept is the remaining constant. Now there are other ways to express the equation of a line. Point-slope form is another way to do so. The point-slope form is a way to express the equation of a line using a specific point along the line and the slope, m. So the point-slope form is y minus y1, the y-coordinate of that specific point, is equal to m, our slope, times x minus x1, x1 being the x-coordinate of the point. So essentially, you have the slope of the line, and you have any point along this line. You plug this point in here and here, the y-coordinate, the x-coordinate, and you plug the slope in here, and then you isolate y on one side, and you would have the equation of the line. So let's say you were asked, what is the equation of the line that passes through the point 3, 2, and has a slope equal to 4? You would plug this 3 in for x1, you would plug this 2 in for y1, and you would plug in positive 4 for m. So again, the point slope form is y minus y1 is equal to m times x minus x1. The x1 is the x-coordinate of the point, so that's positive 3. y1 is the y-coordinate of the point given, so that's 2. So it's y minus y1. So although this point is positive 2, we get y minus 2. This subtraction is a part of the formula. Same thing here. It's x minus 3 because x1 is positive 3. So you plug that in right here, x minus 3. And now step 2, you replace m with 4. So now we've successfully plugged in our point and our slope into the point slope form. And now you want to isolate y on one side so that you have this equation in y is equal to mx plus b form. But before we isolate the y, we must first distribute this 4. So step 3, distribute the 4 to each term. So you multiply the 4 times the x and the 4 times the negative 3. Since this is in a set of parentheses beside the 4, we're multiplying them. So 4 times x gives you 4x. 4 times negative 3 gives you negative 12. So we wind up with y minus 2 is equal to 4x minus 12. So now we want to isolate our y. So we add 2 to both sides to get rid of this negative 2, leaving us with y is equal to 4x. Negative 12 plus 2 is negative 10. So the equation of the line using the point slope form winds up being y is equal to 4x minus 10. Let's have you try a few practice questions. What is the equation of the line that passes through 3, negative 6 and has a slope equal to negative 2? Question number 2. What is the equation of the line that passes through negative 1, 7 and has a slope equal to 3? And question number 3. What is the equation of the line that passes through 5, negative 2 and has a slope equal to negative 4? Pause the video, answer these 3 questions, and then press play when you are ready to begin. Okay, so to find the equation for these lines, we're going to use the point slope form. Y minus y1 is equal to m times x minus x1. So we were given a point for each of these 3 questions. So for those points, you plug the x-coordinate in here, the y-coordinate in here, and then you take the slope that was given and you plug it in for m. So step 1, replace x1, y1 with 3 and negative 6. So we get y minus negative 6. That will wind up being y plus 6 is equal to m times x minus 3. Our x is positive 3. X minus positive 3 is x minus 3. Step 2, replace m with negative 2, the slope. So this is what we are left with. And now we want to distribute this negative 2 to each of these 2 terms. So we wind up with y plus 6 minus a negative turns it into plus. Y plus 6 is equal to negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. So we have y plus 6 is equal to negative 2x plus 6. But we need to isolate y on one side. So step 4, subtract 6 from both sides. And that leaves us with y is equal to negative 2x. So this would be the equation of the line for question number 1. And we see it has a slope of negative 2 and a y-intercept of 0. Question number 2. Step 1, replace x1, y1 with negative 1 and 7. Y minus y1 is y minus 7 is equal to m times x minus x1 minus negative 1 is the same as plus 1. So this is what we are left with. And then step 2, replace m with positive 3. And now we want to take this 3 and distribute it to this x and this 1. So step 3, distribute the 3 to each term. So we get y minus 7 is equal to 3 times x, which is 3x. 3 times positive 1 is positive 3. So we have y minus 7 is equal to 3x plus 3. And now to isolate y on the left side, step 4, add 7 to both sides to negate this negative 7, leaving you with y is equal to 3x plus 10. 3 plus 7 would give us 10. Question number 3, step 1, replace x1 and y1 with 5 and negative 2. Step 2, replace m with negative 4. Now we want to distribute this negative 4 to each of these terms. And here, y minus negative 2 becomes y plus 2. So we have y plus 2 is equal to negative 4 times x, which is negative 4x. Negative 4 times negative 5 is positive 20, leaving you with y plus 2 is equal to negative 4x plus 20. To isolate y, we want to negate the positive 2 by subtracting 2 from both sides, leaving you with y is equal to negative 4x plus 18. 20 minus 2 would give us positive 18. So this is one way in which you'll be able to use the point-slope form if you're provided the point and the slope. But there's another case in which you'll be able to use the point-slope form, and that is if you're provided with 2 points on that line instead of the point and the slope itself. So in this case, if 2 points from the line are provided but not the slope, use the points to calculate the slope and then use the point-slope form. So you'll use these 2 points to calculate the slope of this line. So you'll have m, and then you can use the first point in the point-slope form with the slope to figure out the equation of the line, or you can use the second point with the slope that you found in the point-slope form to calculate the equation of the line. Let's walk through an example of this. What is the equation of the line that passes through the points 3, negative 1, and 0, 5? So again, we're going to use the 2 points provided to calculate the slope, and then we'll use that slope with this point or this point to figure out the equation of the line. Now step 1, subtract the second y-coordinate from the first y-coordinate. In step 2, subtract the second x-coordinate from the first x-coordinate. This is the second coordinate provided. So subtracting this from this would give you negative 1 minus 5, which is negative 6. But you can also use this point first and this point second. So you can also do 5 minus negative 1 in our numerator to get your delta y. You'll get negative 6 in the first example and positive 6 in this one. But once you find delta x, in this one, since you subtracted the second point from the first, in the denominator, you subtract the second point from the first as well. So you get 3 minus 0, which gives you 3. In this one, we subtracted the first point from the second point. So we do the same thing in the denominator. We do 0 minus 3 instead, which gives us negative 3. So our negative is in the numerator up here, but it's in the denominator down here. So for step 3, when we divide delta y by delta x, negative 6 divided by 3 is the same as 6 divided by negative 3. So after step 3, we wind up with negative 2 for our slope in both examples. So I wanted you to see that your final slope will be the same regardless of if you subtract this point from this one or if you subtract this point from this one. The most important thing is whatever the first one is, so this is your y coordinate from here. So in the denominator, your x coordinate from the same point has to go first. This one is second, so this one has to go second as well. Down here, this one is first, so this x coordinate's first. This one's last, so this one's last. As long as you keep your x and y's together and they go in the same order, you'll wind up with the same slope. We wind up with a slope of -2. Now we use this slope -2 with either the first point or the second point in the point slope form, and then we'll have the equation of the line. Regardless of which point we use, we'll wind up with the same equation, as you'll see here. So let's say we're using the first point. Step 4, replace x1 and y1 with 3 and -1. And then step 5, replace m with -2. So now we want to get y isolated on the left side. So we want to distribute this 2 to each term on the right, and then move this constant over to this side. So step 6, distribute the -2 to the x and to the -3. -2 times x is -2x. -2 times -3 is +6. So after we distribute the -2, y minus -1 is y plus 1 is equal to -2x plus 6. And to isolate y, step 7, we subtract 1 from both sides, giving us y is equal to -2x. 6 minus 1 is 5. So we wind up with the equation y is equal to -2x plus 5. This is when we use the first point. We can plug in the second point with the same slope, and we'll still wind up with -2x plus 5. So if we go back to step 4, now we'll use y2 or x2. You can plug in 0 here or 5 here. Now I'm showing you both. If you were asked this question, you would do one or the other. Unless your instructor tells you to do both, you could use the first point or the second point, and you'll still wind up with -2x plus 5. So here's step 4. We plug in 0 for x2 and 5 for y2. And then we plug in -2 for slope for our m. And now step 6, we distribute the -2 to each term. -2 times 0 is just 0. So we just need to distribute the -2 to the x. So we wind up with y minus 5 is equal to -2x. And now step 7, we add 5 to both sides. So we get y is equal to -2x plus 5, which is the same equation that we got when we used the first point. So again, in this case, to use the point slope form, use the 2 points given to calculate the slope, m, and then use either the first point or the second point in the point slope form with the slope that you find to get the equation of the line. Let's have you do a few practice questions. Question number 1. What is the equation of the line that passes through -1, -4, and 2, 5? Question number 2. What is the equation of the line that passes through 0, 4, and 2, -6? And question number 3. What is the equation of the line that passes through -2, -1, and 3, 9? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the points -1, -4, and 2, 5. Step 1, subtract the second y coordinate from the first y coordinate. So if you subtract this point from this point, you'll get -4 minus 5, which is -9. if you subtract this one from this one, you'll get 5 minus negative 4, which gives you positive 9 in the numerator, which is our change in y. Step 2, subtract the second x coordinate from the first x coordinate. So if you subtracted this point from this point, right, negative 4 minus 5, then in the denominator you have to use this x coordinate first, so it'd be negative 1 minus 2. Negative 1 minus 2 would give you negative 3 in the denominator, your change in x. Here, we did 5 minus negative 4. So in the denominator, this one goes first. We have 2 minus negative 1. 2 minus negative 1 becomes 2 plus 1, which gives you 3. So step 3, divide the delta y by the delta x. The delta y is the numerator, delta x is the denominator. So when you divide negative 9 by negative 3, you'll get positive 3. 9 divided by 3 is positive 3. So we see that our slope is equal to positive 3. Now we'll use this slope of positive 3 with either the first point or the second point in the point slope form to calculate the equation of the line. So for using the first point, step 4, replace x1 and y1 with negative 1 and negative 4. Y minus negative 4. X minus negative 1 is x plus 1. Replace m with our slope of 3. And now we want to distribute this 3 to x and 1. 3 times x is 3x. 3 times positive 1 is 3. So we wind up with y minus negative 4, which is y plus 4, is equal to 3x plus 3. And to isolate y on one side of our equation, we want to get rid of this positive 4. So we subtract 4 from both sides. 3 minus 4 is negative 1. So we wind up with the equation of y is equal to 3x minus 1. So this is if you use the first point, negative 1, negative 4. You could have also used the second point, 2, 5. So if you replace x2 with 2 and y2 with 5, and then you replace the slope with 3, and now step 6, you want to distribute this 3 to the x and negative 2. 3 times x is 3x. 3 times negative 2 is negative 6. So we wind up with y minus 5 is equal to 3x minus 6. We want to isolate y on the left side of our equation. So we'll add 5 to get rid of this negative 5. That leaves you with y is equal to 3x minus 6 plus 5 is minus 1. So again, we wind up with the same equation when we use the second point. Y is equal to 3x minus 1. Let's take a look at question number 2. We were given the points 0, 4, and 2, negative 6. So we were going to use the 2 points to calculate the slope of the line. So step 1, subtract the second y-coordinate from the first y-coordinate. In this top example, we'll do this point minus this point. In the bottom example, it's if you did this point minus this point. So for our delta y's, you'll get 4 minus negative 6, which is positive 10. Or you would have gotten negative 6 minus 4, which is negative 10. In the denominator, this point minus this point, you get 0 minus 2, which is negative 2. Or if you did this point minus this point, you got 2 minus 0, which is positive 2. For step 3, when you divide delta y by delta x, 10 divided by negative 2 is negative 5. Negative 10 divided by 2 is also negative 5. So we see our slope for this line is equal to negative 5. We'll then use this slope in either one of these points in the point slope form to figure out the equation of this line. So we can use 0, 4, or we can use 2, negative 6. To use the first point, step 4, replace x1 and y1 with 0 and 4. Step 5, replace m with negative 5, our slope. And now we'll want to distribute this negative 5 to each of these terms. Negative 5 times 0 is just 0, so we won't need to do that. So when we distribute the negative 5, we wind up with negative 5 times x, which is negative 5x. And now to isolate y, we want to add 4 to both sides. So when we add 4 to both sides, we get the equation y is equal to negative 5x plus 4. If you use the second point instead of the first point, you'll also get this same equation. So if you replaced x2 and y2 with 2 and negative 6, you would have gotten y minus negative 6 is equal to m times x minus 2. You replace m with the slope of negative 5. And now you'll want to distribute this negative 5 to the x and the negative 2. So that's step 6. Negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. So we wind up with y minus negative 6, which becomes y plus 6, is equal to negative 5x plus 10. We want to subtract 6 from both sides to get rid of this positive 6. So we wind up with y is equal to negative 5x plus 4. In question number 3, we were given the points negative 2, negative 1, and 3, 9. Again, this top calculation is if you did this point minus this point. This bottom calculation is if you did this point minus this point. So step 1, subtract the second y-coordinate from the first y-coordinate. So negative 1 minus 9 would give you negative 10. Or 9 minus negative 1 would give you positive 10. Step 2, subtract the second x-coordinate from the first x-coordinate. Negative 2 minus 3 would give you negative 5 for your delta x in this first example. Or 3 minus negative 2 would be 3 plus 2, which is positive 5. Step 3, divide delta y by delta x. Negative 10 divided by negative 5 is positive 2. Positive 10 divided by positive 5 is positive 2. So our slope is positive 2. Now we take that slope and combine it with either the first point provided or the second point provided in the point slope form to figure out the equation of the line. So step 4, replace x1 and y1 with negative 2 and negative 1. And then step 5, replace m with positive 2. Now distribute this 2 to each of these terms for step 6. 2 times x is 2x. 2 times positive 2 is positive 4. So we wind up with y minus negative 1, which is y plus 1, is equal to 2x plus 4. Step 7, subtract 1 from both sides to get rid of this 1, leaving us with y is equal to 2x plus 4 minus 1, which is 3. So the equation of the line that passes through those 2 points is y is equal to 2x plus 3. Let's say you use the second point. You replace x2 and y2 with 3 and 9. And then step 5 would have been to replace the slope with positive 2. Step 6, distribute this 2 to each term inside the parentheses here. 2 times x is 2x. 2 times negative 3 is negative 6. So we wind up with y minus 9 is equal to 2x minus 6. To isolate y on the left side, we'll need to add 9 to both sides, which gives us y is equal to 2x. Negative 6 plus 9 is positive 3. So again, we wind up with the same equation. Y is equal to 2x plus 3. So those are two different ways in which you can use point-slope form to calculate the equation of a line. Let's now discuss parallel lines. Two lines that have the same slope are considered to be parallel, and they will not cross in the coordinate plane. So let's say you have line number 1 and line number 2. If they're parallel, that means their slopes are the same. So that means they are rising and running at the same rate. So because of this, they will stay on the same trajectory, just in different locations in this plane. So their y-intercepts will be different. The location where they cross the y-axis is different. The only time you'll have parallel lines that cross is if they are the same exact line. All right, so just look out for that unique case on your quiz or exam. So if you are told that two lines are parallel, you know one slope is equal to the other. But let's say you are given the equation of one line and the point on another line. How would you figure out the equation of this line? Well, the point-slope form can be used to find the equation of a line if a point from the line plus the equation of a parallel line are given. Well, if we are given the slope of the second line, that means this slope is the same as we mentioned, so we could plug that in for m. And if you are given a specific point on the line you are trying to find, then you can plug in that point for x1 and y1, and then you use the point-slope form to figure out the equation of this line. So let's walk through this. Let's say you are given -1, 2 is a specific point on this line. You plug in -1 for x1. So x minus -1 would give you x plus 1. You plug in 2 for y2. You have your slope 2 plugged in. So with the point-slope form, now we can isolate this y to get the equation of this line. And that would give us y is equal to 2x plus 4. So that is just a snapshot of how you would utilize this method to figure out the equation of a parallel line. Let's have you walk through another example from start to finish. What is the equation of the line that passes through the point -2, 4 and is parallel to y plus 3x is equal to 5? So the first thing we'll notice is the equation of the line can be given in standard form, but as we saw, we want to have it in slope-intercept form. So the first thing we'll do is change this from standard form to slope-intercept form. So y plus 3x is equal to 5. Step 1, we'll subtract 3x from both sides to give us y is equal to -3x plus 5. So this is the equation of the line that is parallel to the one that we are looking for. So why did we want to change this to slope-intercept form? It's because now we see that the slope of the parallel line is -3, and we were given the point -2, 4 on the line that we are looking for. So now we use the slope and the point in point-slope form to calculate the equation of the line that we're looking for. So step 2, replace x1 and y1 with -2 and 4. X minus -2 gives us x plus 2. And then we get y minus 4 on this side. In step 3, we replace m, our slope, with -3. And now we have everything we need to figure out the equation of the line that we are looking for. So step 4, distribute the -3 to each term, our x and +2. -3 times x is -3x. -3 times 2 is -6. So now we are left with y minus 4 is equal to -3x minus 6. So step 5, add 4 to both sides so that we can negate this -4. -6 plus 4 is -2. So the equation of the line that we were looking for is y is equal to -3x minus 2. Let's have you try a few practice questions. Question number 1. What is the equation of the line that passes through 2, 5 and is parallel to y minus 4x is equal to 1? Question number 2. What is the equation of the line that passes through -4, 3 and is parallel to y plus 2x is equal to 3? And question number 3. What is the equation of the line that passes through -2, -4 and is parallel to y minus 3x is equal to -1? Pause the video, answer these questions, and then press play when you are ready to begin. So you are given the equation of a parallel line, but it's in standard form. You want to switch it to slope-intercept form. So for question number 1, the first step is to add 4x to both sides. This allows you to isolate y on one side, and that gives you y is equal to 4x plus 1. This is significant because the line we are looking for is parallel to this line. So the coefficient of our x is our slope 4. So 4 will be the slope of the line that we're looking for as well. And we know the point 2, 5 exists on that line. So we use the point slope form with this information to find the equation that we're looking for. So step 2, replace x1 with 2 and y1 with 5. Step 3, replace m with 4. And now we have the information that we need to figure out the equation of the parallel line. So step 4, distribute the 4 to the x and the -2. 4 times x is 4x. 4 times -2 is -8. That leaves you with y minus 5 is equal to 4x minus 8. You want to isolate y. So to get rid of this -5, step 5 is to add 5 to both sides. -8 plus 5 is -3. So we see that the parallel line that we're looking for in question number 1 is y is equal to 4x minus 3. Question number 2. Step 1, subtract 2x from both sides. This gives us a slope-intercept form of y is equal to -2x plus 3 of the parallel line. So this gives us the slope we're looking for, -2. We combine that with the point on the line we're looking for in the point slope form. And step 2, we replace x1 with -4, and we replace y1 with 3. X minus -4 becomes x plus 4. Y minus 3. Step 2, replace m with -2. Now we have the information that we need to figure out the equation of the line. Step 4, distribute the -2 to each term. -2 times x is -2x. -2 times 4 is -8. So we have y minus 3 is equal to -2x minus 8. In order to isolate y, we want to get rid of this -3. So step 5, we add 3 to both sides, leaving you with y is equal to -2x. -8 plus 3 is -5. So we get y is equal to -2x minus 5. And now question number 3. We're given y minus 3x is equal to -1 as the line that is parallel to the one that we are looking for. So we want to change it to slope-intercept form. So step 1, add 3x to both sides, giving you y is equal to 3x minus 1. This lets us know that the slope of the parallel line that we are looking for is 3. And we are given the point -2, -4 on that line. So if we use point slope form, we want to, step 2, replace x1 with -2 and y1 with -4. X minus -2 becomes x plus 2. Y minus -4 becomes y plus 4. And then step 3, replace our slope m with 3. We now have the information that we need to figure out the equation of our parallel line. So step 4, distribute the 3 to each term. 3 times x is 3x. 3 times +2 is +6. So we have y plus 4 is equal to 3x plus 6. We want to isolate y. So to get rid of +4, step 5 is to subtract 4 from both sides, giving us an equation of y is equal to 3x plus 2. Now you can encounter similar questions for perpendicular lines. Two lines that have slopes that are negative reciprocals are called perpendicular lines, and they will cross at a right angle. So let's say you have line number 1 and line number 2. They cross to form 4 right angles. So these are each 90 degrees. And if their slopes are negative reciprocals, that means when you multiply them times each other, you'll get a product of -1. So let's say this slope was -1/2. To find the negative reciprocal, you multiply it by -1, so the negative becomes positive. And the reciprocal means that you switch the denominator with the numerator. So instead of 1/2, you'll get 2/1, which is 2. So we get +2 instead of -1/2. And if you multiply these times each other, you'll get -1. So this is also what it looks like. One of the slopes is equal to -1 divided by the other slope. And the other slope is equal to -1 divided by the other slope. -1 divided by -1/2. If you are dividing the numerator by a fraction, it's the same as multiplying the numerator by the reciprocal. So -1, if you switch the 2 and the 1, you get -2 instead of -1/2. So -1 divided by -1/2 is the same as -1 times -2. So that will give you -2 times -1, which is 2. Same thing the other way. If you had -1 divided by one of the slopes, you get -1/2. And that would be equal to this -1/2. So that is the relationship between two perpendicular lines and their slopes. And if you multiply those two slopes, 2 times -1/2, again, you'll get -1 as a product. Let's have you walk through one of these questions from start to finish. What is the equation of the line that passes through the point 0, 3 and is perpendicular to 2y plus x is equal to 2? So this is similar to our parallel lines. We're given a perpendicular line in standard form. So we'll want to change this to slope-intercept form so that we can figure out what the slope is. That will help us figure out the slope of the line we're looking for, and we can use this point. We then use that slope and this point in the point-slope form to figure out the equation of this line that we're looking for. So the first thing, we want to take the standard form and change it to slope-intercept form. So step 1, subtract x from both sides. That gives us 2y is equal to -x plus 2. To get rid of this coefficient of 2, step 2 is divide both sides by 2. So the equation of the perpendicular line that we are provided with is y is equal to -x/2 plus 1. And this is significant because this allows us to figure out the slope of that perpendicular line, which is the coefficient of the x, which is -1. 1 times x is the same as x. So although we don't see the 1 is there. So the coefficient is -1/2. And we can use this slope to then figure out the slope of the perpendicular line that we are looking for. So step 3, to figure out that slope, we want to divide -1 by m1 by -1/2. So when we divide -1 by -1/2, negative divided by negative is positive. And when you're dividing by a fraction, it is the same as multiplying this numerator by the reciprocal. So instead of 1/2, this is the same as 2/1. 1 times 2 would give us 2. So the slope of the line that we are looking for is 2. And we are given the point on that line, which is 0, 3. So we combine the slope with the point given in point-slope form. And now we can figure out the equation of the line that we are looking for. So step 4, replace x1 with 0 and replace y1 with 3. Then step 5, replace m with our slope of 2. Now we have all the information we need for that perpendicular line. So step 6, distribute the 2 to the x and the 0. 2 times 0 is 0, so we won't need to do that. 2 times x is 2x. To isolate y, we want to add 3 to both sides. So we wind up with y is equal to 2x plus 3. Let's now have you try a few practice questions. Question number 1. What is the equation of the line that passes through -4, 1 and is perpendicular to y plus 4x is equal to -1? Question number 2. What is the equation of the line that passes through 6, 8 and is perpendicular to y plus 3x over 2 is equal to 1? Question number 3. What is the equation of the line that passes through -2, 12 and is perpendicular to y minus x over 5 is equal to -3? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. The line that is perpendicular to the one we are looking for is given in standard form. So we want to change it to slope-intercept form. So step 1, subtract 4x from both sides. This shows us that the equation of that perpendicular line is y is equal to -4x minus 1. This is significant because that tells us that the slope of that line is -4. So if m1 is equal to -4, to figure out the slope of the perpendicular line, step 2 will be to divide -1 by -4. -1 divided by -4 is equal to 1/4. A negative divided by a negative is positive. 1 over 4 is 1/4, which is the same as 0.25. So we use the fact that we have this slope and a point on that line in the point-slope form to figure out the equation of the perpendicular line that we are looking for. So step 3, replace x1 with -4 and y1 with 1. X minus -4 is equivalent to x plus 4, y minus 1. And now step 4, replace m with 0.25. Now we want to distribute this 0.25 to each term. So that's step 5. 0.25 times x is 0.25x. 0.25 times 4 is 1. And now to isolate y, we add 1 to both sides, step 6, leaving us with y is equal to 0.25x plus 2. Or if you want this as a fraction, 0.25 is the same as 1/4. So that would change to x over 4. So we get y is equal to x over 4 plus 2. Let's take a look at question number 2. We want to change it to slope-intercept form. So step 1, subtract 3x over 2 from both sides. This gives you y is equal to negative 3x over 2 plus 1. So we see that the slope of this first line is negative 3 halves. So we want to divide negative 1 by negative 3 halves. Negative 1 divided by negative 3 over 2. You want to multiply the numerator 1 by the reciprocal 2 over 3. So negative divided by negative is positive. 1 times 2 over 3 would give us 2 over 3. Remember, when you're dividing by a fraction, it's the same as multiplying the numerator by the reciprocal. The reciprocal means that you switch the 2 and the 3. You switch the numerator and the denominator. So 1 times 2 over 3 is 2 over 3. So this is the slope of the line that we are looking for. We combine that with the point on the line 6, 8. So step 3, replace x1 with 6 and replace y1 with 8. In step 4, replace m with 2/3. Now we have the information we need to figure out the equation of the line that we are looking for. So step 5, distribute this 2/3 to each of these terms. 2/3 times x is 2x over 3. 2/3 times negative 6 is 2 times negative 6, which is negative 12 over 3. Negative 12 over 3 is negative 4. And now step 6, add 8 to both sides to get rid of this negative 8. That gives you negative 4 plus 8, which is positive 4. So the line that is perpendicular is y is equal to 2x over 3 plus 4. And now question number 3. You were given the line y minus x over 5 is equal to negative 3, which is in standard form. This is the line perpendicular to the one that we want. So we want to switch this to slope-intercept form. So step 1, add x over 5 to both sides. That shows us that the line has an equation of y is equal to x over 5 minus 3. That means the slope of this line is 1 over 5. Step 2, to find the slope of the perpendicular line, the one that we want to divide negative 1 by m1, which is 1/5. Negative 1 divided by 1/5 is the same as negative 1 times positive 5. The reciprocal is 5 over 1. So negative 1 times 5 is negative 5. So this is the slope of the line that we want. Plus, we were given the point negative 2, 12. So step 3, replace x1 with negative 2 and y1 with 12. X minus negative 2 becomes x plus 2, y minus 12. And now step 4, replace m with negative 5. Now we have the information we need to figure out the equation. So we want to distribute this negative 5 to each of these terms. So negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. So now to isolate this y, we want to add 12 to both sides. Negative 10 plus 12 is positive 2. So that gives us the final equation of y is equal to negative 5x plus 2. So that is how you would use the point slope form with perpendicular lines. Let's now wrap things up by discussing graphing. We'll discuss how to graph linear equations as well as inequalities in this section. So the graph of an equation can be sketched with 3 unique x-coordinates being plugged into the slope-intercept form. So if you had one point and you plotted it on the coordinate plane, you had a second point from this equation and a third point. Since a line is going to continue with the same slope, 3 points with a consistent slope is all you need to see what that line would look like. And once you draw a line through these 3 points, you'll get a sketch of the line. Something else you want to be aware of is called the table of values. As the y-coordinates of a line are being calculated, a table can be used to record the corresponding x and y coordinates. So before you get the 3 points to plot, you need to figure out what 3 points exist on that line. So you can plug in any x-coordinate into the equation and then get the resulting y. And you plug in that x and y into this table. And the third column would be the resulting x and y coordinate. And once you do this 3 times, you'll have the 3 points that you can then plot on your coordinate plane. Now, throughout this chapter, the x coordinates that I'll be plugging in are -1, 0, and 1, just because it's pretty common to want to sketch the line close to where the axes intersect. So just for the sake of consistency, I'm going to use -1, 0, and 1 for our x coordinates. We'll plug those values into the x in the equation, and we'll get the resulting y. Now you'll notice, in order to do this, we'll need for the equation to be in slope-intercept form, so that when we plug in an x value, the resulting y value is isolated by itself. So let's take a look at a question like this from start to finish. If you're graphing a line, step 1, plug 3 different x values into the equation. So let's say you were given the equation y is equal to 2x plus 4 and you wanted to sketch this. We're going to use -1, 0, and 1 for our x values. So step 2, you record each x and y coordinate in a table of values. So we plug in -1 for x. -1 times 2 is -2. -2 plus 4 would give you +2. So -1 for x gives you a final value of +2 for y, giving us an xy coordinate of -1, 2. So we record that in our table, and we do this a total of 3 times. The second time, instead of -1 being plugged in for x, we have 0. 2 times 0 is 0. 0 plus 4 gives you a y value of 4. So in our table, we have 0 for x and 4 for y, giving us an xy coordinate of 0, 4. And we do this a third time by plugging in 1 for x. 2 times 1 is 2. 2 plus 4 is +6. So our third coordinate is 1, 6. Once you have your table of values, we have the 3 points along the line we want. So we can plot these 3 points. That's step 3. And then once we plot them, we draw a line through the points, and that will be the sketch of the line. So our first point is -1, 2. So you go to -1 along the x-axis, you go up to +2 on the y-axis, and you plot that point. 0, 4, plot that point, and then 1, 6. Now we have our 3 points, so we want to draw a line straight through. And that would give us the sketch of y is equal to 2x plus 4. Let's now have you sketch a few lines. Sketch each line. Question number 1, y is equal to -2x plus 4. Question number 2, y is equal to 3x minus 1. And question number 3, 2y minus 4x is equal to 10. Pause the video, sketch each line, and then press play when you are ready to begin. Question number 1, we are given the equation y is equal to -2x plus 4. Step 1, plug 3 different x values into the equation. And step 2, record each xy coordinate in a table of values. So for our x values, we're going to use -1, 0, and 1 in each question. So if we plug in -1 for x, we get -2 times negative 1, which is positive 2. Positive 2 plus 4 is equal to 6. So our first coordinate is negative 1, 6. We replace negative 1 with 0. 0 times negative 2 is 0. 0 plus 4 is 4. So our second point is 0, 4. And then our third point, we're going to use x as 1. Negative 2 times 1 is negative 2. Negative 2 plus 4 is positive 2. So our third point is 1, 2. Now we have our 3 points in our table of values. So step 3, we want to plot these points. And step 4, we'll draw a line through the points. So our first point is negative 1, 6. Our second point is 0, 4. And our third point is 1, 2. Once we have our 3 points, we'll then draw a line through the 3 points. And that will give us the sketch of y is equal to negative 2x plus 4. Question number 2. You were given the equation y is equal to 3x minus 1. Step 1, plug 3 different x values into the equation. So again, I'll plug in negative 1, 0, and positive 1. And step 2, we'll record each xy coordinate in a table of values. So when we plug in negative 1 for x, 3 times negative 1 is negative 3. Negative 3 minus 1 gives you negative 4. So our first point is negative 1, negative 4. When we plug in 0 for x, 3 times 0 is 0. 0 minus 1 is negative 1. So our second point is 0, negative 1. And then our third point, we're going to use x is equal to positive 1. 3 times 1 is positive 3. Minus 1 gives you positive 2. So when x is 1, y is 2. So now we have the 3 points of this line. So step 3, we want to plot the 3 points. And then step 4, we'll draw a line through the 3 points. So we'll go to negative 1, negative 4, plot that point. 0, negative 1, plot that point. And then 1, 2, plot that point. And now once you've plotted the 3 points, you want to draw a line straight through the 3 points to give you the sketch of y is equal to 3x minus 1. And now question number 3. We were given 2y minus 4x is equal to 10. So we want to change this to slope-intercept form before we start plugging in values. So step 1, add 4x to both sides to give us 2y is equal to 4x plus 10. To isolate this y, we want to get rid of this coefficient of 2. So step 2, divide both sides by 2, giving us an equation of y is equal to 4x divided by 2 is 2x, 10 divided by 2 is 5. So this is the equation that we want to sketch. Y is equal to 2x plus 5. So once we have that equation, step 3, we can follow our normal steps now. Plug 3 different x values into the equation. So we'll plug in negative 1, 0, and 1, as we did previously. And step 4, we'll record each xy coordinate in a table of values. When we plug in negative 1 for x, 2 times negative 1 is negative 2, plus 5 will give you positive 3. So that gives you negative 1, 3 as your first point. When we plug in 0 for x, 2 times 0 will give you 0, plus 5 will give you 5. So you get 0, 5. Then lastly, 2 times 1 will give you 2, plus 5 will give you 7. So you get 1, 7 as your third point. And now step 5, plot the 3 points. In step 6, draw a line through the points. So we plot negative 1, positive 3. We plot 0, 5. And we plot 1, 7. They're on the same trajectory, so we can draw a line straight through. And this would be the sketch of y is equal to 2x plus 5. Let's wrap things up by discussing how to graph an inequality. Graphing inequalities is very similar to graphing linear equations. So let's say this line represents y is equal to 2x plus 1. This shaded region are the values that are greater than 2x plus 1. So if this were y is greater than or equal to 2x plus 1, we have the line, so that's y is equal to 2x plus 1. Greater than 2x plus 1 is above it. Where is y greater than? Well, at this point, y is greater up here than it is down here. At this point, y is greater here than it is here. At this point, y is greater here than it is here. So for greater than inequalities, shade above the line where the y values are greater. And for less than inequalities, shade below the line where y values are smaller. So y is smaller than or equal to 2x plus 1. This is 2x plus 1, so that's equal to, so it's a straight line. Less than is below, since the y values are lower here than they are here. Or if you look at the y-axis, the y values are smaller here than they are here. So again, for inequalities, greater than is above the line, less than is below the line. Now, another thing you want to keep an eye on is the actual line when you're sketching an inequality. The or equal to inequalities have a line that is solid since these points are included in the inequality. It's or equal to, so equal to is a possibility. So all of these points are possibilities. But if it were y is less than 2x plus 1, the line y is equal to 2x plus 1 is not included. So the less than or greater than inequalities have a line that is dotted. Since these points are not included in the inequality, the dotted line just represents where the limit is. Okay, so a straight line represents that those points are included. A dotted line represents the limit, or which points are not included. Let's walk through graphing an inequality. Step 1, change the inequality sign to an equal sign. So let's say you were given y is less than x plus 3. We're going to change the inequality to equal to give us y is equal to x plus 3. This will allow us to graph the line the same way we just did in our previous section. And then we'll come back and shade the appropriate region last. So step 1, change the inequality sign to an equal sign. And now we proceed to collect 3 points along that line, and we'll sketch those 3 points. So step 2, plug 3 different x values into the equation. And step 3, record each xy coordinate in a table of values. So again, I'll use the x values of -1, 0, and 1 for each example. So when you plug in -1 for x, you get -1 plus 3, which gives you a y value of +2. When we plug in 0 for x, 0 plus 3 is 3. So our second point is 0, 3. And our third point, when x is 1, 1 plus 3 is 4. So our third point is 1, 4. So now we have our 3 points. So we want to plot these 3 points. And then step 5, instead of drawing a straight line, we're going to draw a dotted line through the points. Since we know the inequality that was given is y is less than x plus 3 instead of y is equal to x plus 3. So we plot -1, 2. We plot 0, 3. And we plot 1, 4. And again, since it's less than, not equal to, we'll draw a dotted line instead of a straight line. And since it was less than, we're going to shade the area below the dotted line for step 6. So this would be the sketch of y is less than x plus 3. Let's wrap things up by having you sketch a few inequalities. Question number 1, sketch y is less than 4x minus 2. Question number 2, sketch y is greater than negative 2x plus 1. And question number 3, sketch y minus 3x is less than or equal to 5. Pause the video, sketch these 3 inequalities, and then press play when you are ready to begin. Question number 1, you were given the inequality y is less than 4x minus 2. Step 1, change the inequality sign to an equal sign. So that gives you y is equal to 4x minus 2. We'll then use this equation to figure out 3 points along that line, and then we'll plot those 3 points. So step 2, plug 3 different x values into the equation. So we'll use negative 1, 0, and 1. In step 3, we'll record each xy coordinate in a table of values. So when x is negative 1, 4 times negative 1 is negative 4. Negative 4 minus 2 is equal to negative 6. So when x is negative 1, y is negative 6. If x is 0, 4 times 0 is 0. 0 minus 2 gives you negative 2. So our second point is 0, negative 2. And then when x is 1, 4 times 1 is 4. 4 minus 2 is positive 2. So that gives us a third point of 1, 2. Now step 4, plot the 3 points. And since we were given y is less than 4x minus 2, we're going to draw a dotted line through the points instead of a straight line. So we plot negative 1, negative 6, 0, negative 2, and 1, 2. So we have our 3 points. And again, since the inequality we were given was less than, it's not a straight line but a dotted line. And since it was less than, step 6, shade the area below the dotted line. So this would be the final sketch of y is less than 4x minus 2. Let's now have a look at question number 2. You were given the inequality y is greater than negative 2x plus 1. Step 1, change the inequality sign to an equal sign. This will give us y is equal to negative 2x plus 1. Step 2, plug 3 different x values into the equation. So we'll use negative 1, 0, and positive 1. And then step 3, we'll record each of these xy coordinates in a table of values. So when we plug in negative 1 for x, we get negative 2 times negative 1, which is positive 2. Positive 2 plus 1 gives us 3. So when x is negative 1, y is equal to 3. When we plug in 0 for x, we get 0 times negative 2, which gives us 0. 0 plus 1 gives us 1. So when x is 0, y is 1. And our third point, when we plug in x is 1, we get negative 2 times 1, which is negative 2. Negative 2 plus 1 is negative 1. So when x is 1, y is negative 1. So now we have the 3 points that we would like to plot. So step 4, plot the 3 points. Go to negative 1 on the x-axis, go up to positive 3 on the y. 0 is here, so we go up 1. So that's 0, 1. And we go over 1 and down 1 to 1, negative 1. And now we draw a dotted line through those points. And step 6, shade the area above the dotted line. Above represents greater than. Since it's not equal to, that is why we had the dotted line instead of a straight line. So this is what the sketch of y is greater than negative 2x plus 1 would look like. And then lastly, question number 3. We were given y minus 3x is less than or equal to 5. We want to get y isolated on the left side. So step 1, we add 3x to both sides, giving us an inequality of y is less than or equal to 3x plus 5. Now we can change the inequality sign to an equal sign, giving us y is equal to 3x plus 5. So when we graph the final inequality, we'll use a straight line since it's or equal to that line or the limit. Those points will be included. So we'll have a straight line instead of a dotted line. We want to find 3 points along that line. So y is equal to 3x plus 5. Step 3, we'll plug 3 different x values into the equation. We'll plug in negative 1, 0, and 1. And then step 4, we'll record those x, y coordinates in our table of values. So when x is negative 1, we have 3 times negative 1, which is negative 3. Negative 3 plus 5 is positive 2. So when x is negative 1, y is 2. When we plug in 0 for x, 3 times 0 is 0. 0 plus 5 is 5. So our second point is 0, 5. Then lastly, when x is 1, we get 3 times 1, which is 3. 3 plus 5 is 8. So when x is 1, y is 8. And now we have 3 points. So step 5, plot these points. Go to negative 1, 2, plot that point. 0, 5, plot that point. 1, 8, plot that point. So now we have our 3 points. And since we had or equal to in the inequality, the line that we sketch, these points are included. So it's a straight line, not a dotted line. In step 7, shade the area below the line. Since our inequality was less than or equal to, less than is the area below the line. So this would be the sketch of y is less than or equal to 3x plus 5. And that wraps up this chapter on lines. If you have any follow-up questions, feel free to leave them in the comment section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.